One thing, this goes all the way back to Unit 1 with descriptive statistics. If you don't have unimodal symmetric data without outliers, so if any of those conditions aren't met, it's always best to use median and interquartile range. So in this particular case, it is suspected that we have outliers, it has suspect outliers. So in this case, even if everything else was looking good, it's best to use median and interquartile range. Remember, if you have outliers that are, you got this right here, but then you got a couple of points over here, what this is going to do, these 2 points are going to throw off your standard deviation, and it'll throw off your mean too, but I think even more so it's going to throw off your standard deviation, maybe both fairly evenly. And so we don't want to deal with that kind of stuff. Okay. We have progress made. All right, that's good. Now you need to take the test technically before you can join in this progress, but most of you are taking the test, and there's a little bit to talk about. We're actually gonna have a pretty short class today. Well, I say short, let's hope so, but we're not gonna be talking about a whole lot, and in a little bit we'll talk about how this unit will go. But look at this. We started over here at least fair. We've made it all the way down to, look at this. This is real progress we're making. We made it down to Crystal Rapid. Okay, Crystal Rapid. Let's see what that's like. Let's see what that's like. All right. So here are some pictures of that. So maybe this is how you're feeling right now. Hopefully that probability test went pretty well for you. Maybe it didn't. But, maybe you're feeling like it's a bit overwhelming, and yeah, that can happen. So Crystal Rapid is one of the big ones on the Grand Canyon. I think this one's slow motion. So if I show this, it should be slow motion so you can see some of the fun here. Otherwise, you'll get a choppy video. Yeah, it slows down here, so you should be able to see it well enough. All right, fun stuff. So hopefully you're not feeling that way, but hey, we're making it down the river slowly but surely, aren't we? So this is some minutia here that I just wanted to go through. Progress checks. I think there are some people who are taking care of their progress checks, but you're not exactly sure what you're supposed to do in order to turn them in, quote, so that I know you get them done. So when you guys do the progress checks, if I don't go to AP Classroom, I have no idea if you finished it or not. So I like to just have it all in one place. So I'd like for you guys to turn that in on Canvas. And here's what that looks like. So if you go over to Canvas, you have this section right here. You don't see all these things. I haven't opened them up yet, but AP Progress Check Semester 1. And you have these actual assignments. So let's say you've been doing all your progress checks, but you haven't been turning anything in. You can go back to your AP Unit 1 progress check. And there is an assignment for you to turn in. And all you have to do is submit this to say done. And that's it. Submit the assignment. And there you go. And that is just a way for me to know that you have actually done the progress check. I will go back and double check it later, but in the meantime, this is just a really quick check for me to know that you've gotten it done. All right. Hopefully that makes sense. Any questions on that? Okay, next one, you can see it right here. Homework, turn in all old homeworks for half credit. So if you are looking at your grades in Student View and you're realizing that you haven't gotten everything done yet, that's not a big deal. Well, it kind of is a big deal. Hopefully you're keeping up with stuff, but you can go back to any of these homeworks. If you know there's some you didn't do, like this February 3rd homework, you just come over here, turn it in late, and you'll get half credit. That's better than getting nothing. All right, so make sure you're taking care of all this stuff. Let's see what the next thing is. Test retakes. Remember, you can do one test retake per semester, and there's not like a time that you have to do the retake, except it has to be done before the end of the semester. But if we're getting to the point, we're doing 7 units this semester, and we're on the 6th one right now. So if you're already looking back and you're like, yeah, that unit 3 is definitely the one I'm going to want to retake, then you can already start scheduling that retake. If you want to wait until unit 6 is over with, you'll have some time during unit 7 to get that done. But if you want to wait till after unit 6 is over, see how you do there, and then pick, whatever the case, but just want you to have that on your radar. Even if you did really well, you can still do a retake. Let's say that you've done really well on all your tests, and you just want to do a retake just to try and bump your high B up into an A. Take advantage of that too. Or if you're at an A, so sorry, just to belabor this a little further, if you're at an A, but you want to bump up your grade even higher just to make sure you don't drop that down, feel free to do a retake. It's open to everybody. Okay, the AP test. If you are planning on taking the test or you're considering it, that would be great for me to know. And I don't know if you want to private chat to me to let me know, like, hey, I am signing up, or I already did sign up. That would be good for me to know. I'll eventually find out, but it might not be for another month until I get that information. So if you could tell me sooner rather than later, it'd just be good to know, because I'm already looking ahead to the kind of the crash course in statistics that we're going to be doing in the spring. Anyways, just be aware of that. If there are some scholarship opportunities, meaning you could have your AP test paid for, what I've heard about is Hispanic and Indigenous students have some scholarship opportunities. If you believe you qualify for that, then I would contact the Native American or Hispanic, well, actually just contact Mr. Marks about that if you think you might qualify and you're interested in the AP test, or any AP test, even if it's not statistics. All right, the last thing, and maybe you guys already read this. So this is going to make you feel a little better. Everyone is going to take the midterm for this class, but, and this does not apply to the final, but for the midterm, I'm only going to count the grade if it brings your grade up. So if you're worried about like keeping your grade and you have to take that midterm, it's going to drop you down. Luckily, you're in luck. Whatever you have going into the midterm, you'll keep. But if you're sitting close to that cutoff point, you want to bump it up to a B or something, then that's where you can really get one extra bump in your grade. So that's just some random stuff to talk about here at the beginning of class. And with that, if there are any questions on these things, then certainly please, talk to me about it. Let me know if there's something that you wanted to get clarification on or some help with. Okay, let's move into Unit 6. This, I don't want to scare anyone at the beginning. There are a few units that I think it's really new information. Maybe everything up until now, you've kind of had some kind of a basis to build on. You're like, okay, I'm learning some new stuff, but I already know a little bit about normal distributions. And you might have some basic knowledge. This, I think, is going to be one that's going to be very new for you. I don't know if you would have seen stuff like this in the past. So just to prepare you for it. And, if you talk to people from this stats class, maybe they will say that this stuff is really hard. Maybe they'll say it wasn't so bad. You'll get a mix of opinions, but let's just jump into it. We're going to start today, and we're only going to focus on expected values. And we're going to start with a little activity, which is how many vehicles are at your home? And you can go ahead and add a dot on here. And just to get more data, if you have like a friend's house that you go to a lot, then why don't you add 2 different houses? So like in my house, I have 1 car, but I have some good friends and they have 2 cars. So I'm going to add 2 dots just so we can get more data. So before we do anything with this, I just want to talk about right here. This is a discrete random variable, and that's what we're going to be working with, are discrete random variables. And discrete means that it only takes on specific values. Like in this case, it can only be integers. Well, specifically what we call the natural numbers. You can have 0, 1, 2, 3, 4, so on. You can't have negative cars. Though some of you might hate your car so much you feel like it's a negative car. I don't know. Random variable, this is what this unit is really built around. Random variables, it's a variable that represents a random phenomena, and we know its outcome depends on a random event. Okay, it doesn't say it there, but basically we know the values that it could take, but we don't know exactly which value it's going to be, and we'll see how that comes into play as we develop this idea. So if we want to find the average of this data set, we need to find a weighted average. We need to weigh each outcome by the probability that the random variable will take on that value as its outcome. And if this sounds confusing right now, it does get resolved pretty quickly. All right, so the mean, let's go ahead and establish this right now. When we're talking about expected value, we're referring to the mean. So right here, we could kind of guess, right? I would guess that the mean is going to be somewhere between 2 and 3 here. I don't know. Let's just guess 2.8. We'll see how, and you can come up with your own guess in your head. So I might guess 2.8 is the mean. We're going to find out exactly what it is. And that means anytime we randomly find out how many cars over the long run, we would expect on average 2.8 cars to be at a house. Okay. So there we go. It's also called the expected value. Okay, and this is where now we're going to do the math. So notice it's the sum of all of the values, x, times the probability of that value. So if we had 16 data points, and there's only one, I can't believe I'm the only one that only has 1 car. All right, so we've got 1 out of 16. The probability that if I picked from this data set, for 1 car, there's only 1 in 16. This is a 4 in 16 probability. This is 1, 2, 3, 4, 5, 6, 7, 8 in 16 for this one. And then it'll be, I just want to make sure we did our math right. Yep, we did 3 in 16. So it all works out. So these are the probabilities. The parentheses don't mean anything notation-wise. I just want to separate it out. So here's what I'm gonna do. I want to find out the sum of this. So I'll just call it the expected value right now. The expected value of x, and maybe it's worth talking about right now. This right here, when we're referring to random variables, we always use a capital letter. That will come up again. I think that's probably what we're going to talk about tomorrow. But capital letters mean it's a random variable. Okay. So it's going to be the sum of all of these different outcomes times the probability. So my first outcome is there could be 1 car times the probability of that, which is 1 in 16. All right, I'm going to add to that the probability that there's 2 cars. And I'm going to multiply that by the probability. I'm going to go ahead and simplify that down. That's 1 in 4. Plus, there could be 3 cars at a house. And there's a 1 in 2 probability that a car has 3, or that a home has 3 cars. Plus, there could be 4 cars, and there's a 3 in 16 probability of that. So let's go ahead and do this math. Well, luckily, 1 times 1/16 is this. I'm going to put this into decimal at this point. So that's 0.06, 625. All right, and you guys can do this individually and we'll just figure this out. All right. Do you guys agree with the numbers I have? Okay, we're getting the same stuff. I will show you guys a faster way of getting this done, but we can do it by hand also. Okay, so if these numbers are all correct, we need to add it up, so go ahead and do that. There we go. So from this, now granted, this is some empirical probability. It's not over, it's not found any, but this is empirical. But from this data set, we would say that the expected value is 2.8125. So my guess was pretty spot on, though I don't think that shows like some kind of a amazing ability I have. I mean, we probably would have thought it's going to be somewhere in the middle, but a little over to the right. So hopefully you're all kind of on the same page with that 2.8 probably being where the mean was. And that's exactly where we found it, 2.8125. And just to repeat myself one more time, this means if we were to pick with these probabilities over and over and over and over and over again, then we would expect on average 2.8125 cars to be at a house based on all the different outcomes. All right, so nothing too bad with this. Let me go ahead and clear that out of the way. So let's see, well, we're going to develop this some further. We have a bunch of practice problems with this. And we're going to look at this. So now we've got a lottery, and here are your outcomes. You could have $5, 10, 20, 50, 100 as your winnings. And now part of the rules with lottery games, and at least I believe this is true across the nation, they do have to tell you the odds of getting any particular outcome. So you can actually look this up. If you looked at any lottery game in Arizona, you went to the grocery store, or, the gas station, you could, assuming you're old enough to buy one, you could actually look on the back, and I believe on there it's supposed to say what the odds are for any given outcome. But anyways, moving forward, one thing that's not shown in this is the probability of getting $0. So the $0 is going to be everything else. Now we can figure out what that is. So this goes back a little bit, and that says everything else, just doesn't look like it. So remember, a valid probability distribution is one where you have all of these probabilities have to add up to 1. So the sum of that is going to be 1. So we could figure out what that other probability is. I will say in practice, it doesn't really matter because we're going to be finding an expected value. And what that would mean, I would take this outcome right here, 0 times the probability of 0. And it's going to be 0 times it, so it all cancels out anyway. So we don't really care what the probability of 0 is, but we could figure it out. All right, just hopefully that's good. So what I can do is I can figure out what these probabilities are. And it's probably easier for this just to go ahead and convert this into decimal. So I'm going to do that. We know 1 in 5. That's 0.2. And you guys can calculate this on your own. It's always good to have a little sheet of paper nearby during class. Yeah, okay. So I think those are the probabilities. I don't think I made a mistake, but correct me if I did. So at this point, we can do the expected value of this, and we can do this by hand. We're going to see some more examples. So let's do this last one by hand, and then after this, I'll show you how to do it faster using the calculator. So I've got all my outcomes in the top row. So sometimes we write it like this. We'll see, sorry. What's going on? Okay, sorry, my thing isn't following very quickly. So this, we could say that's X, and this is a probability of X. All right, so now we're just adding them all together. So 5 times 0.2 plus 10 times 0.025 plus 20 times 0.01 plus 50 times 0.001 and then 100 times 0.0002. So if I, do that, and let's see what the answer is. And I won't put the answer down. I will just put an equal sign, and you guys can put the answer in whenever you find it. So $1.52. And that's really what that means. Remember that our unit started as dollars. So this is in dollars. Our expected value here is $1.52 in winnings. So the question is, if this cost $1 to play this game, would you play? And to clarify, we're thinking statistically, not morally, because maybe you just think gambling is always wrong. But statistically, would you play this game?
Yes, morals are for the rich.
Okay, there we go. And why would you play this game?
Because if I'm paying $1 to play this game and the expected outcome is $1.52, I have a good odd of making more money than what I started with. But if it was $2 to play the game, I'd be losing money.
There you go. That's the idea. Now, of course, any given outcome, if you just play this one time, you're going to get 0, 5, 10, 20, 50, or 100. Those are your only outcomes. All right. And it's most likely going to be 0. So when we talk about expected value, remember, this is the value over the long term. So you wouldn't just pay $1 and call it good. This is the kind of thing, and there are people who look out for good plays like this, and you want to pay you want to play this like 100 times, 1,000 times, because yeah, you're going to have a lot of games where you lose and you get $0, but then you're going to have a lot of games where you get 50 or $10, and then by the time you're all done, if you spent $1,000, then you're most likely going to walk away with around $1,500. So that's, I will tell you this: in casinos, anytime you play, there's always an expected value less than whatever the cost is.
Mr. Davis, how much money have you made gambling?
I have made no money.
Damn, I was kind of surprised. I feel like you'd be the kind of guy to count cards or something and be like secretly rich.
You think a math teacher is going to be a gambler?
I can see it.
No, that's
exactly
what they don't do.
Well, I mean, there's actually a video. I think I have it posted. Maybe I don't yet. But I posted some of these videos in the Canvas classroom. I don't know if you guys have looked at the different pages and seen some of the videos that I post on a given day. Anyways, one of them, it has someone working in a casino, and he basically says, if you're going to a casino, your best bet is it doesn't really matter the game, maybe craps or something, but you go and you take however much money you're willing to bet. If you come in with $100 you're willing to gamble with, just take the $100, put it all on red, play one game, and you either win it all or you either double it or you lose. But you're never going to get better odds than that in a casino. If you're one of these people, you're like, I'm just going to pay $5 for this game, this one. Well, then you're just nickel and dime yourself to nothing. So the longer you play, the more the odds shift into the house's favor. So if you
Is that because it's like a math thing, or is it because they stack the odds against you when you do that? Because it would almost seem like you'd get better odds because you're doing more like attempts.
It's every single margin in favor of the house is very small. So it's not like the house wins 90% of the time. No, the house wins like 52%, 55% of the time. But just that small margin is enough. So basically, I know we're talking, it's gambling talk. But
see, this is the kind of stuff we need to learn in school so we don't waste our money when we're adults.
The probability of, let's say that you want to win, well, and this is what we're actually kind of getting into it to some degree, but let's just say, what's the probability that you could win if you have a 48% chance of winning? What's the probability that you could win, 10 times in a row? Well, that's just 0.48 to the 10th power. And this isn't the best example, but you can see that the more times you play, that this probability goes down. So if you just do 0.48 to the 10th power, you can see that's down to like minuscule percentages. It's like 0.06%. So there's very small chance you're going to win 10 games in a row.
So let's say for a second that like the odds were tilted in your favor. Would that make sense if you were doing it like multiple times, or is it still just going to be infinitely smaller?
Oh yeah, if it's in your favor, then playing many times is your best bet. If it's not in your favor, just playing it like once or very few amount of times, and then walking away, that's your best bet.
That makes sense.
Okay, so the last question, we came up with $1.52 as the expected value. So how much would you be willing to pay to play this game?
Up to $1.50.
Okay. And this is kind of more of a subjective question. You could statistically answer it. If you're going to play this game 1,000,000 times, then just 1 penny each time is great. But if you're only going to play this few, then it's like, well, how much is my time worth? So it's kind of subjective. I wouldn't want to play if I couldn't get 50 cents on my investment. So whatever, let's just move forward. Let's look at this more. Let's find the faster way of doing this. All right, so now we're going to use our calculators. All right, so notice that we've got, let's not do both of these. I don't think we need to do both. If you want to come back and do both examples, we can. But we have 4 outcomes right here, 100, 200, 300, 400. Let's create a list with those outcomes. So stat, edit. If you have any lists, you can clear the list. Don't delete them. Just go up to the name of the list and hit clear. And then you'll have a clear list. So anyways, 100. All right, pretty simple to create that list. Now, in the list next to it, I want to put the probability distribution. And notice that this does add up to 1. So it's a valid list, but in the same order. So I'm going to put 0.1, then I'm going to put 0.2, and then 0.5 and 0.2.
Could you go over quickly how to get there on your calculator again?
Yeah, you hit stat and then edit, and that'll take you to your lists. And it doesn't matter which 2 lists you pick, though you do want to have the first outcomes. So on my calculator right now, I have list 1, list 2, and it looks like this.
Yeah, no, I got it. I was going to a list, the actual button that said list.
Oh,
so,
gotcha.
my bad.
Yeah, I'll just finish showing this for completeness, but also in case anyone else needs to see it. So that's what it looks like for me right now. Now, if you go to, you can get out of this. You can go back to stat, over to calc, And the very first one variable stats. We've done this before, but we always skipped over the frequency list. You have list 1 for your list. Your frequency list is going to be where you put your probability distribution. That's list 2. So you can hit 2nd and 2. So again, you're going to have list is list 1. Frequency list is going to be list 2. And then you can calculate, and it's going to give you your expected value, your X bar. Remember, it's your mean. So in the long run, we would expect to get 280 as the value from this. Okay, so that's pretty straightforward. Now we know a faster way of doing this. And we don't need to really worry about these other numbers right now. Okay. If you need to see that again, I can run through it on another problem. So now we're going to run into ones where they don't give us a probability distribution, and we need to kind of figure this out now. It's going to be a little bit more challenging, maybe a lot more challenging. So here's the game. You roll a die. It comes up, if it comes up 6, you win $100. If not, you get to roll again. If it comes up 6 the second time, you win $50. If not, you lose. We want to create a probability model for the amount we're going to win, find the expected amount, and then would you be willing to play this game? Okay, that's kind of subjective in the end. So let me do this. I've got the X and the probability of X. What are the outcomes of this game?
You get a 6.
That's a good guess. It's actually not one of the outcomes. That's kind of one of the actions, one of the mechanics as part of the game. But what is the actual outcome?
You
You'll
win.
win $100.
Win $100. So I could win $100. Great. What's another outcome?
$50.
50. Are there any other outcomes?
You don't win any money.
You don't win any money. Are there any other outcomes? Well, as you can see, I got to the end of my table, so no, there's no more. But I mean, it's good to think through that, kind of have that critical thinking going on. You're like, okay, I know these outcomes. Is there anything else that's possible? And until you satisfy yourself that, no, that's it. So what's the probability we win $100?
1 in 6.
1 in 6. We'll worry about the fractions later, or the decimals. We'll convert this later. What's the probability that we get $50?
One in 12.
No? Let me put it in notation first. It's the probability of what happens first and then what happens second. Let me put it this way. I roll the die one time, and what do I get?
Not a 6.
Not a 6. So I'm going to put 6 complement right here. And then I roll it again, and what do I get?
A 6.
A 6. So if I'm going to find that probability, what am I multiplying together?
Five 6 times 1 6.
That's it. 5/6 times 1/6, which is, just a second. That's going to be 5/36. Again, we'll convert this in a minute into decimals. Decimals are easier to work with. Though you can plug this into your calculator just like this. Maybe that we'll do it. Okay, so in the other case, we get not a 6 in the first one, and then what do we get?
Not a 6.
Not a 6, which is 5 out of 6 times 5 out of 6. And we can see that's 25 out of 36. So actually, let's not even worry about converting this to decimals. You can do this in your calculator. Let's find the expected value. You already know, go into your lists, and we have new outcomes to plug in. So I got 100, 50, and 0. And now for my probabilities, I'm just going to put in 1 divided by 6, and it'll do the math for me. And 5 divided by 36. Okay, now this should, if we did this right, I believe we did, this should add up to 100%. All right, I was just looking at that real quick, making sure. But there we go. I'm going to do my one variable stats. I got my list and my frequency list set. The expected value is, go ahead, write that, someone who's found it. $23.61. All right. So there we go. Those are the main questions. And so hopefully everyone was able to follow along with that. And the last one, what would you be willing to play? It's a subjective thing, but I will tell you there is a wrong answer. You should never pay more than $23.61. So anything above that or equal to it is wrong, but anything below that is fine. Okay. If there are any questions, I'm kind of delaying a little bit. You can let me know before we move on. Okay, you know what I think I want to do on this one? Let me see, how many problems? Okay, there's only 2 more. I'm gonna have you guys, I'm just gonna pause the video. I'm gonna let you guys work on this one individually, see what you can come up with. Okay, I'm gonna break into your thinking now. Hopefully you're able to think through some of it. Does anyone know what some of the outcomes could be? Maybe you thought through all of them.
Is it winning $1, $2, $3, and $400?
Well, the way that we're going to play is, and that's actually a good thought, but we're going to play it where as soon as we win the $100, we're done playing. So so that's a good question. Okay. So I didn't think about that perspective on it. If we don't limit it that way, it gets very complex. So let me ask this question. If you hit a balloon on your first game, what's your outcome?
You win the $100.
You win the $100, and how much money are you out?
$5.
$5. So if that's the case, then you're at, well, what's the outcome there?
$95.
95. There we go. $95. That one's going to be our simplest case. Now, let's say if it's on the second dart that you hit it, what do you win?
You'd still win 95.
Well, at that point, you threw it twice. So how much have you spent?
Oh, so you'd win 90.
90. There you go. All right. You hit it on the third throw. What's your takeaway?
85.
Okay, we can see. All right, I'm going to give myself a little bit more space. You hit it on the fourth throw.
$80.
80. And then you throw it 4 times and you miss. What's your takeaway?
Negative 20.
Negative $20. Okay, so now we can kind of go through this. So for the first one, I'm going to put this in notation first. And maybe I'll do it like this. So I'm going to give myself another row right here. So this is going to be probability twice, but the first one I'm just going to put the notation. The probability getting 95 is the probability of a success the first time. I'll just say that. So what's the probability of success?
.1.
0.1. Okay. So that one is kind of the most straightforward. Now think about what the next one would be. What happened in this scenario?
Not successful the first time and then successful the second.
Fail and succeed, which means our probability is going to be
.09.
0.09. That is right. I'm going to put that down here. So in case you guys didn't get that, it's 0.9 times 0.1. All right, and now we can probably see what we're doing from here. 85, what's the probability?
Fail, then success.
You got it. So I'm not going to worry about the last part. I think you guys can handle that. What's the next what's the next probability going to be?
Fail, success.
All right. And then the last one would be?
Failing 4 times.
You got it. So this represents all the outcomes, and there we go. Let's go ahead and figure that out. Go ahead and put in the numbers whenever you find them. You can just fill in those blanks on the bottom row. Okay. those numbers look good to me. You can actually just plug this in to your lists, and we can now figure out what the expected value of this will be. I'll go ahead and put this right here. Someone write in the expected value whenever you find it. So that that looks right to me. That's what I got for my answer. Depending on rounding at different points, you should be in that ballpark. So you might be off by a penny or so from there. All right. So if you played this game, your expected outcome is $17.20, and you're willing to spend $20. So this seems like a bad bet, but if you're trying to impress someone around you, then maybe it's worth it. Or maybe it's a terrible, terrible idea. Just look like a fool. But hey, you live your own life. All right. So we only have one more problem to look at. Okay. Maybe this one I'll let you guys think through a little bit more. All right. Anyways, a man buys a racehorse for $20,000, enters it into 2 races. He plans to sell the horse afterward, hoping to make a profit. If the horse wins both races, its value will jump to $100,000. If it wins one of the races, it will be worth $50,000. If it loses both races, it will be worth only $10,000. The man believes there's a 20% chance that the horse will win the first race and a 30% chance it will win the second one. Assuming that the 2 races are independent events, find the man's expected profit. Wow, this one's going to get complicated. All right. So I will give you guys about 2 minutes to think through this independently, and then let's come back together and I'm going to see if you guys can talk me through it. So I just want to start off with the question, what are the outcomes of this scenario?
I
Winning.
put,
Go ahead.
I put 80,000, 30,000, and negative 10,000.
Perfect. 80,000, 30,000. And while I'm writing that, how did you come up with those?
I did 100,000 minus 20,000, and then 50,000 minus that, and then 10,000 minus that.
Okay. And it's probably clear, but just to make sure it's clear, where does the 20,000 come from?
The amount he spends on the horse.
There you go. That's a sunk cost right now. We're going to have to subtract that from whatever winnings we get. So there we go. If everyone's good, those are the 3 outcomes. Now for the probabilities, this gets a little bit different here. So what do we do with this?
To win the 80,000, you have to win both races. So you would multiply the chances of winning each individual race together.
There you go. Probability of a win and a win. Let's create another row for this. So we know that it says here 20% chance he wins first race, 30% chance he wins the second one. So there we go. We just multiply those together. And we get a probability of
0.06.
0.06. All right. So we're good with the first one. I want to skip over to the last one real quick. How do you end up with negative 10,000?
If he loses both races.
Okay, probability of loss and loss. So what are the probabilities for losing?
0.8 and 0.7.
All right, we multiply that together, we get?
I got 0.56.
0.56. All right. So for this last part, we have two options for how to find it. And I'll let you guys try and answer this. What's one way we could find this missing probability?
Add the probability of winning the races together.
Okay, yeah. Are you saying add these together?
Yeah.
All right, no, it wouldn't be that. Some good thinking, but that's not it.
Is it 1 minus 0.06 and then minus 0.56?
There you go. We know what the probability of the two outcomes are, so the third has to be whatever's left over. That's 0.62. This should be 0.38. All right, so we can figure that out. Now we can figure it out. That's kind of the working smarter, not harder sort of way. But we could also kind of brute force our way through this one, because we have, what are the possible ways of a horse winning only one race?
It loses a first and wins a second, and then vice versa.
There you go. So it could be win and loss, or it could be loss and win. And it's either one of these, so we have to add these together. So this is going to be a little bit more complex, but I'm just going to show this. So we already know the probability of winning the first is 0.2 times the probability of losing the second is 0.7 plus, so that's kind of the first outcome. And the second one where we lose the first one, that's a 0.8 probability. And we win the second, that's a 0.3. So if we do this, that's the calculation that we'd have to do. But if we do that, we should get 0.38. And you can verify that one. And I believe it comes out correct. So as far as fully explaining, there you go, I got some thumbs up. As far as fully explaining your thought process, this is probably, like, actually showing this work right here is probably the better thing to do. But it is, to be fair, it is an acceptable thing to do to say, well, this has to be the complement. So I just took whatever we got for the other two outcomes and subtracted it from 1 to get 0.38. All right, so at this point, that's the hard part of this problem. You can figure out the expected profit. Let's just do that real quick, and I will put that right here. Someone can write that in when they get it. $10,600. That's your expected profit. Now, keep in mind, this is your expected profit. And so actually, if we go back to the previous problem, I was saying that wrong. Your expected profit on that balloon game was $17. So you're actually expected to be in the positive because we already took into account the sunk cost in the cost of the game. This is already factoring in the cost of the horse. So if you did this, this is your job, and you did this every single year and you bought lots of horses and you did this with it, then of course, assuming these probabilities stay the same, then you could expect to get $10,600 off of every horse. There you go. If you're looking for a lucrative endeavor, that's your takeaway from your stats class. All right. If you have any questions about this stuff, certainly stick around. We can go through some other examples. You have these problems in your book to work on tonight. We're going to look at chapter 16 some more tomorrow. And actually, before you guys go, I wanted to talk about a little bit more. I'm not going to record this part of it, so this is the end of the video.